All right, folks, we're ready back to start again. Our last unit on statistics. This first part is a lot of terminology and vocabulary. So you're going to have to spend some time studying just the vocabulary. It's not a lot of math involved in this very first part. So that's where you need to focus, is to be sure you learn the terminology and understand the terms, so that as we move on into some of the mathematical part, it will make a little better sense to you as you use the terms with the math part. So this first unit is just about familiarizing yourself with some of the special vocabulary terms that are used a great deal with statistics. So I'm switching over again to the note page. And as we start, we want to talk about the different branches of statistics. If you take, a lot of you will take a more advanced statistics class, and we are just scratching the surface in what we are going to do in statistics. We're focusing mostly on the first branch, which is called descriptive. As you take more advanced statistics, you get into the second branch. But descriptive statistics is more about the collection, the organizing, the summarizing, and the presenting of the data. Through some simple numerical summaries. Most of the things that are involved in descriptive statistics you have seen in one form or another through your years of math education. Inferential statistics is where you get more in depth. This is where you're going to generalize and draw conclusions. From the data that you've collected. You also get into measuring the reliability of the results. So the two branches, descriptive and inferential. Again, we're still focusing on the descriptive, but when you take your next level of statistics, you will go more into the inferential part. So that term sampling, what does that mean in terms of statistics? This is the segment of statistics that gathers the information and that information is used in both the descriptive and the inferential parts. So sampling is when you gather your information. Sampling methods. Pretty much what it means is the methods that are used to collect the data. But not only is it used to collect it, but it's also part of deciding what needs to be collected. So one of the first things that has to be developed is the statistical question before you start your sampling. And that statistical question has to have, or it must have the characteristics of more than one source, and it must have variability. So let's look at some questions to decide if they are statistical questions. Okay, how tall are basketball players? Is that a statistical question? Are you getting that information from more than one person? Yes, you are. Are they going to have a varied answer? There's going to be different heights. Is that true? Yes. So is this a statistical question? Yes. If I asked, how tall are you? Is that a statistical question? No, because I'm only getting that information from you. You will only give me one answer because you are only one height. If I went to the entire classroom and asked that from each person and gathered it for the entire classroom, then that would make it a statistical question if I was gathering that for the entire classroom. How many miles is the sun from the moon? Is that a statistical question? I could look that up in different sources, so I have that different sources, but regardless of where I look that up, the answer is only going to be one amount. I'm only going to be so many miles from the sun to the moon. So is that a statistical question? That is not. What did you eat for supper last night? If I only ask you as a person, that's not a statistical question. If I want to survey the classroom and ask everyone in the classroom what they had to gather data, then it becomes a statistical question. So the context in which you're asking that question does affect whether it might be a statistical question, but the individual question, what did you have for supper last night, is not in itself a statistical question. If I'm collecting information about the number of people in your family, again, if I ask you individually, that is not a statistical question. If I'm surveying the class, it does become a statistical question. So sometimes that statistical question is not just individually if I look at that individually, it's not a statistical question. If I indicate that I'm doing it for a class or a particular group, it does make it a statistical question. So by adding what time did the students in the class get up this morning, by adding that in the class to that statement makes that a statistical question. So that is one of the first steps of looking at being able to develop sampling, is look at the statistical question. All right, the next part of sampling is to look at the variables. Whether it's a characteristic of an individual or an object, that part really is not important. It is something that you are focusing on to collect your data. It has to be able to be counted or measured or classified to be able to create your data. Once the statistical question is determined, Then the variables for the study can be determined. Now, your variables fall into two categories. Either they are going to be quantitative, or qualitative. Qualitative variables can be broken down into ordinal or nominal. Quantitative variables can be broken down into discrete or continuous. So what's the difference? What's the difference between being quantitative and being qualitative? Quantitative variables are considered numerical. You can provide a measurement. You can count it. Or do arithmetic with it. Add, subtract, multiply. To distinguish between discrete and continuous, discrete is only countable, where continuous is measurable. So qualitative is considered a category. It allows you to classify. Now, there are some exceptions here. Things like zip codes. A zip code is numeric, but it fits under the qualitative category because you really can't do arithmetic with zip codes. You can't add them, you can't subtract them. It classifies a region. So a zip code, even though it is numerical in nature, it is still a qualitative value. It's also like putting a number on a jersey. It classifies that player. It is not something that you do arithmetic with. You don't add and subtract jersey numbers. It classifies them. So there are exceptions to that rule. You kind of have to watch that. So different kinds of variables. So far, we've looked at the branches of statistics. We talked about sampling, the fact that you have to get your data. We've looked at the sample statistical question. We have to develop the question, and then that helps us to decide what the variables are. And then we've looked at the types of variables that there are. So we're ready to get the data. We're ready to do the some method to actually get our data. And we generally use an experiment, which means we perform a treatment, or we have an observation. Observational means that you might go out and observe and watch and count and record. You might do a survey. So these are the two main types of methods to collect data, either doing some kind of experimental treatment or doing an observational technique. And then, of course, there's always some kind of exception to that. And there is something that is called capture, recapture. And this comes into play a lot with scientists studying things that just can't have experiments done, or things that can't be controlled in your normal sense of control. Things like monitoring the population of the deer count, or monitoring the population of the fish in a pond. They use a technique that's called capture, recapture. And what they do is they go out and they capture, in particular, deer. They tag them, they release them back into the wild and let them live for a length of time, say a year or two. Then they go back out in that area, in that region, and recapture the population of deer. And in that population, some are tagged and some are not tagged. And they have this method of counting them to determine how the population has grown or shrunk in that environment. So capture, recapture is sometimes called tag and release. And they use it to help monitor populations in particular. There is a formula that they use to calculate the population, and here's the formula. It's just you're going to use a proportion to do this particular problem. You're going to take the number that are tagged in recapture over the total number in recapture, and you set that equal to the number originally tagged, and it's going to give us our population. So let's look at an example problem. We have 100 deer that we tag and release. One year later, we recapture 75 deer. 25 of those are tagged. And we want to estimate the population. So following this formula, the number that were tagged in recapture was 25. The total in the recapture was 75. The number that was originally tagged was 100. And we don't know the population. That's what we're looking for. So this is a proportion. We're going to cross multiply. So 25 times the population equals 7,500. Divide by 25, the population is now 300. So methods to collect data. We have experimental and observation, and then we have this third method that's used in special situations, the capture and the recapture. Now, what are the concerns with sampling? We have to be aware there are concerns. There are three major concerns. One of the first concerns is how random is the sample? Was it collected? Randomly? Or was it done conveniently? Which is what typically happens. The second concern about sampling is the bias. Bias can be in the wording of questions that you ask people. Bias can be in the way that you ask the question, your inflection in how you ask. There can be bias in where you collect the data. There could be bias in the sample that you get your data from. If you're trying to determine if people like a particular restaurant or not, if you only question the people who continue to go back to the restaurant time and time again, you're only getting people who like the restaurant. You're not getting people who tried it once and never come back to see why they may not have come back. The third concern about sampling is the size of the samples. A lot of times, the size of our samples are not large enough, or the population is too large to handle. So those are concerns when we're actually doing our sampling that we have to be aware of to try to avoid when we're doing our own sampling. So what are things that we can do to help battle those concerns? It's how you collect your data. The first one, of course, is to use simple random sampling. That's the simplest way to avoid bias. It's the simplest way to avoid and make your sampling random. However, it's one of the most difficult things to do. The thing about simple random sampling is you have to include every single object. And that's what gets expensive when you do a simple random sample. Before the invention of computers, it was extremely difficult to do, and computers has certainly simplified this process quite a bit. And one of the methods that was used quite often was the use of the phone book. People would just use the phone book in order to get their random sampling from the phone book. And now with computers, they're able to do that in a different way. But simple random sampling is the first choice to make it most random, but it is also one of the more expensive things about sampling. So, what are some other things that can be done? The next one is called stratified selection. And this is where you place your population in smaller groups and then you randomly choose from the smaller groups. An example of that is on your college campuses, you have your seniors, your juniors, your sophomores, and your freshmen. And so if you're wanting to find out how the college campus feels, you select people from each of those groups randomly to get an overall feel of a particular issue on the college. So that's stratified selection. Then we have cluster sampling. And we again group in smaller groups or clusters. And then you randomly select a group. Now the difference between stratified and cluster, these two often get confused. In stratified, you select within each group, where in cluster, you select a particular group where they're grouped together and you select the entire group. So an example would be, we have our student bodies is from different regions. For example, we have people from Northern Virginia. We have people from Tidewater. We have people from Richmond. We have people from Southwest Virginia. We have people from North Carolina. And then we have people from other various places. And so we might randomly select people from Tidewater and people from other places, everybody from those particular groups to get our information from. Not randomly select from each of those groups, but those particular groups only. That's the difference between cluster versus stratified. Another method of selection is called systematic. Where selection is actually a pattern. Every nth person or item is selected. This is especially used in manufacturing. Every 10th item off the product line is checked for defects. Rather than checking each individual item, they randomly check every so often to see if defects are occurring. And then, of course, there is convenience sampling. Whatever is easiest to obtain. An example would be that you need to survey the freshman class. About the cafeteria. But you only survey the people on your hall. You've collected data, you've collected from freshmen, but they might not necessarily be representative of everybody on campus. Convenient sampling is one of the most used techniques for sampling. Might not be the best, but it happens to be what's used most often in sampling. All right, the last little bit I want to finish up with is just to go over the vocabulary terms in particular that we've used in the lesson to be sure that you do understand the vocab. Some of the words that we've used just to be sure that you have a good meaning of them. So one of the terms that we used quite a bit was population. This is the set of all the people or the objects that the data is collected about. At the same time, you will hear the term targeted population. That's kind of the same thing. This is the ones that you wish to desire. You may not always get the data, but this is what you desire to get the data or you wish to get the data on. The term sample is a subset. You've heard that term before, subset or subgroup of the population. So sometimes it is just not feasible to get the entire population. So we use a sample of that population instead. And then instead of sample, you hear the term representative sample. And this sample exhibits the characteristics of a typical sample. Now, when we use the word census in statistics, it's not a census in terms of gathering the information like the every 10 years census. It is the collection of data from every person of the population. When you have a census, that means you got it from everyone. Now, using those particular vocabulary terms, I just want to run through an example problem and show you how to pick out those, use those terms to pick out in a problem So we have the owner of a Latin grill who wants to determine if new items on his menu satisfies the demands and taste of his customers. So he uses a list of 1,000 past customers and sends a survey to 50. So in this problem, what is the population? So in this particular problem, we're looking at what is the population of that particular situation. In that particular problem, it is the 1,000 past customers. What procedure did he use to find his sample data? Well, he didn't use a census because he didn't contact every past customer. Since he sent a survey, that is considered an observational, not an experiment. So it was an observational method. To collect data, not an experiment. We don't have enough information to determine what type of random sampling that he used to pick those 50 people. What is the sample? That is the 50 people selected. So again, I'm just trying to show a situation where you want to be able to decipher within that situation the utilization of the vocabulary in that particular problem. So things that we've talked about and being able to apply it to a particular problem to know what's going on in the problem.